welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 24th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights to the North Pacific Ocean, we see an area that was a gale in the far West Pacific, generated some small seas and tiny swells radiating towards Hawaii. Not uneven enough to really mention. And then remnants of a tropical system, once a super typhoon off the Philippines, pushing actually northeast very early in the year and forecast to redevelop. So, two areas of interest there. Let's dive into the details. So we're going to do things a little bit different tonight because, one, all the weather models, or most of them, are down. We've been having issues with NOAA and the way we get data from NOAA. One of their major servers is having difficulties, has been down for 4 or 5 days now. We're working on an alternative path, not sure if we're going to get there, hoping that their main server, they'll get that fixed and will be off and running. But in the meantime, we're going to use alternate graphics to try to illustrate what's going on. So first off, we're not doing any jet stream stuff this evening because, well, the models are down. But we can look at the surface and see what's going to forecast to go on for the next week. Right now, low pressure as we saw, and you can clearly see it. Counterclockwise circulation, 30 to 35 knot winds in the far northwestern Gulf of Alaska. Not really generating any seas of interest at the moment. And then the remnants of tropical storm Surigay that was off the Philippines, had winds up to 170 knots, I believe, at one point, pushing off to the northeast, forecast to redevelop. In fact, we can see that here. System up here, fading, but look at this. 55 knot winds. Well, let's see. There we are. 55 knot winds over a tiny little area as we get into Monday, and then building fetch of 50 to 55 knots out of the northwest as we get into Monday evening, lifting northeast, quickly fading as we get into Tuesday, but still some seas should be generated, which should produce some swell, which should push over the dateline and eventually reach Hawaii and maybe even the U.S. West Coast. Size, not that big because the fetch only lasted for 12 hours, or his forecast only lasts for 12 hours. But anyway, as we get into Wednesday and Thursday, that all winds down. And given that it's practically May, there's no expectation that anything else after that's going to happen. We're into Sunday now. We are out the whole time period. Out the whole 180 hours out. Nothing more going on there. So let's go look at the effect of those winds on the ocean surface. We're watching right over here. And this is interesting because this is a tropical system that goes extratropical, tapping jet stream level moisture as we get into Monday. Seas building to 32 feet. Monday night, a little, maybe even there, you can see it, 42 feet. We think a lot of that energy is all aimed off to the north, but still 32 foot seas pushing off to the east. Maybe 30, 32, 34, maybe 36 or 38 foot seas even, pushing off to the east right before sunrise on Tuesday, and then fading from there. It is very unusual to have an extratropical system pushing northeast in any direction other than in the fall, much less in April. So now what was driving all this? We harp on the MJO and ENSO and all that kind of stuff. That's what's driving it. A westerly wind burst developing here in the far West Pacific. There's the equator right there. The Kelvin wave generation area is right out to here, okay, and down to about 5 degrees north and south of the equator, so you could draw a box right in there. And we're not going to get into the details now, but that's where this system formed. That's what was driving it all, and this was the first strong active phase of the MJO in almost a year. The first westerly wind burst of any solid magnitude in a year, and it produced a tropical system. So, hence our interest. All right, moving on. As we get out into Wednesday, the gale, storm, whatever you want to call it, extratropical storm, faded out, and we're just going to race through the rest of this because there's really nothing of interest forecast unless you look right off of California as we get a week from now and maybe some wind swell off there. So now we'll play the same game looking south. What's wind-wise, what's going to happen the next week? A tiny little gale is forecast developing right somewhere, where is it? Right there under New Zealand as we get later in the week. What is that? 35, 40 knot winds, lifting northeast, kind of fading. Notice this system fetch all aim south. And then maybe trying to reorganize as we get into Monday, but that seems like a bit of a reach. Let's go take a look at the wave models. So we're going back in time with this to Tuesday, what was it, about 5 days ago, because a small gale did develop in the deep south, we'll call it Central Pacific, far southeast of New Zealand. Small area seas in the, tiny area, 32, 34 foot seas. It says 36 feet. Oh, that was this one over here. Yeah, so about 34 foot seas, pushing off to the east and lifting northeast some, faded, then redeveloped in the southeast Pacific on Friday with 29 foot seas and continuing almost 30 foot seas about midday Friday, then started fading out as we got into Saturday and Sunday. So it made the whole trip across the Pacific small in size, but still tiny swell has been generated, radiating up towards Hawaii and California. Really small size expected, nothing huge, but at least there will be some surf. And then looking forward, another system is forecast under New Zealand. We'll cue that up here as it gets into the frame on, there we go, on Friday. So 5 days of pretty much nothing. And then small gale, what was that, 26, 27 foot seas. So this is actually a downgrade. It was up to 34 foot seas this morning. We'll see whether this actually plays out. Then forecast trying to reorganize over the Central Pacific again with 24, 26 foot seas, something like that, aim northeast. So the short of it is there is one small swell in the water, but beyond that, not so sure whether really there's going to be much from the South Pacific for a bit now. Looking at winds along the U.S. West Coast and into Hawaii, looking for wind swell potential. As of Sunday, trades pushing into the islands about 15 knots. Nothing particularly noteworthy of that. Maybe small wind swell along east-facing shores. Really nothing along the California coast. And that's pretty much, you can see here, a light wind pattern forecast. And even winds lightening up for Hawaii as we get into Monday. It actually looks like with low pressure up in the Gulf of Alaska, cutting the winds out of cutting the energy out of the normal high pressure that has been building here, driving trades. Now we do see trades Tuesday night, 15 knots along the California coast, most of it focused over Point Conception, maybe pockets of little 20 knot winds, but not doing much for any significant wind swell. We're talking like 6-second period wind swell at best. We're into Friday, just looking for anything in here. I can click away just so you can see. The wind is all focused over Point Conception, doing nothing for Central and North California, really. And it's not till you get into even, we're into Saturday, and then winds finally start building in pockets at, 20, 25 knots. And then Sunday is more the day with solid area of 25 knot winds along the North and Central California coast. Wind swell expected. It'll be pretty raw for sure. Let's see where we're at. Whoops, and there we are, 180 hours and building. So maybe the week, so Sunday and maybe Monday and after that, certainly something for California. Also notice trades. In fact, let's go back and look at Hawaii. When do the trades finally start building in earnest? Right about the same time frame as high pressure gets established here. Trades start building on Saturday relative to Hawaii, 15 knots, maybe 20 knots in some pockets. And Sunday looks like a trade wind swell production day for the Hawaiian Islands. Precip potential. All right, so it is actually raining in Northern California and the San Francisco Bay Area. Has been pretty much most of the afternoon. There is snow in the mountains. The model's kind of overhyping it, some we suspect. We actually looked at the cams up there, and at least in the valleys, it's a dusting of snow, maybe more up higher at elevation. This looks worse than it really is. There are not even chain controls up over 80 at the moment. Anyway, as we get into Sunday, the rain and the snow starts clearing out. That is Sunday night into Monday morning. Let's go back to, there's 4 a.m. Monday. By 10 a.m., things starting to clear out. Maybe some scattered showers, light snow showers in the Sierra. And as you get into Tuesday, that's pretty much it. Maybe just a little bit left of lingering snow in the China Peak area, southern Sierras, just east of Fresno and that area, and then things clear out. We'll go out a week and see where we're at. Maybe a light chance of showers as we get into Saturday for Cape Mendocino, and then that's it. We wouldn't expect anything different. So this model actually goes out goes out about 10 days, 240 hours. So no other precipitation. This is probably our final precip event for California for the winter 2021 season. It's not a lot, at least up north here, and it's probably going to be even less the further south you go, but at least it's something. Projected snowfall for Squaw Valley, we're talking 10 inches, and even that seems pretty optimistic because we're supposed to get the 10 inches by about 4 o'clock today, and looking up high, it wasn't even close, and looking down low, it wasn't even less close. So this is probably a gross overstatement. Kirkwood, the same, about 10 inches. And Mammoth forecast to get maybe 2 inches, something like that. We're not looking at the snow levels because this chart is out of date, hasn't updated since the 20th. So it appears to be anything that is at elevation. Jet stream models, temperature model at elevation, snow level or precipitation at elevation. Those charts are having severe difficulties, and so our software is. The data is probably compromised, and it just rejects it rather than printing charts that have just garbage colors and no meaningful data on them. It's just junk, so we've put error code in there to just not produce the charts at all. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation? Of course, the El Nino Southern Oscillation. As usual, we'll start by looking at winds across the equator. This is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but also pretty good for used for monitoring the Madden-Julian Oscillation. And of course, the Madden-Julian Oscillation, two flavors of it, active phase and inactive phase. The active phase is the one we're interested in. It helps support, what it does is it reduces trade. So the MJO is this periodic weather oscillation, travels west to east on the equator. There's two phases, and only two phases in play at any point in time. The active phase in half the planet, the inactive phase is in the other, and they rotate around the planet sort of in an opposite pair. The active phase is effectively a low pressure system. It reduces wind in it. It supports storm production, feeds energy transfer to the jet stream, both in the northern and southern hemisphere. So we're real interested in that because that in turn feeds storm production and then, of course, makes surf and also precipitation. The inactive phase is the exact opposite. It's effectively a high pressure ball. It increases the trades and dries the air around the active phase. All right, so we're looking just at the arrows here. Winds along the equator, out of the east. The longer the arrow, the stronger the winds are. So pretty strong east trades, and these are 5-day average winds. It's not like real time, like the NOAA buoys near shore of the coast. But it gives you a rough idea of what's going on. Strong trades in control of the East Pacific, Central Pacific here, still pretty strong trades. Then the far West Pacific, moderate trades, and weakening as you get further into the West Pacific. But it's not the actual wind speeds that matter. It's the differences from normal for this time of year. And east trades, you see these arrows here? Yeah, they are a bit stronger than normal. But you get to the Central Pacific, and these easterly wind arrows here that's pretty normal. See, there's no real arrow east. It's just the east-west component of the wind we're interested in. When you get to the West Pacific, you see that, yes, this is pretty normal. These winds are normal. And in the far West Pacific, in the Kelvin wave generation area, again, so there's the equator, right? Date line is 180 west, which is right down here. Kelvin wave generation area, 5 degrees north and south of the equator from the far West Pacific, 135 east, out to about 170 west, which is about, right about there. So in this box here, you see trades are very light, or if anything, slightly out of the west. That suggests to us that the active phase of the MJO is over this, what we call the Kelvin wave generation area. When the active phase is here and it's strong enough and it generates westerly anomalies, or if it just deadens the trades, it can take warm water that's normally here, start pushing it off to the east in the form of a Kelvin wave. And then it also supports energy transfer to the jet and can make storms and or rain and precipitation. And of course, this is what helped form that the extratropical, or what is supposed to be helping form the extratropical system in a day or two in the northwest Pacific. And we do have some good news. This chart, the 1 week forecast, zonal wind anomalies for the entire planet, is back up and working. Apparently, the guy that built this chart, Michael Ventris, he's running on servers out of the University of Albany. You know, the thought was, I wrote him, and he said he thought the servers were gone, and that was the end of it. But sure enough, the university got the servers back up and running. His charts are there, and we're off and running. Here's the dead spot when they were down for 10 days or whatever it was. All right, so anyway, here we are today. What are we looking at here? All right, so this is the whole planet on one chart. The date line runs right up the middle here. Okay, the Pacific starts, the far west Pacific, about 135 east, so right about there. And the Kelvin wave generation area ends at 170 west, right about there. And California's at 120, and the East Pacific, or the Central America, the far East Pacific ends right about there. You can see the seam on the picture. All right, but this Kelvin wave generation area we're interested in, right in here. You can see, and yellows and oranges are westerly anomalies. You can see this massive active phase of the MJO was pushing into the Pacific. Pacific starts right about there. So somewhere in the middle of this dead zone. And that's why we were a little bit antsy, because the server went down, and this is right when all this major activity was forecast happening in the West Pacific. But you can see it here. Strong westerly anomalies over the Kelvin wave generation area, feeding energy into the jet stream, and also supporting that tropical development there in the far West Pacific. The forecast for the next week, the active phase of the MJO looks like it's supposed to be moving pretty much out of the Kelvin wave generation area in the next week in south of California. Lighter, weaker westerly anomalies, but any westerly anomalies here in the West Pacific is a huge plus, because you can see how things were. This is pretty representative of how we've been for 6 months. Just strong easterly anomalies nuking over the Pacific Ocean the entire time. This is the first active phase in over a year that's produced any westerly anomalies of any significance. So this is at least a chink in the armor of La Nina, and hopefully signals its demise. But we'll start looking at more indicators here as we get further into the presentation. So let's go look 2 weeks out now. Outgoing long wave radiation, another component of the MJO. Basically, fancy words, OLR, fancy words for cloud cover. The blues means more cloud cover, means more precipitation, typically the active phase of the MJO. You can see, and what do we look at? South America, Central America, the equator right there. There's Hawaii, the New Guinea right there, Australia, Kelvin wave generation area right here on the equator. Active phase of the MJO in control, supposed to hang for about another 5 days. Per the statistic model, then getting very weak, and the reds are high pressure, a lot of sunlight reflecting off the ocean surface, and then no support for storm development starting about 10 days out and solid into 2 weeks from now. Inactive phase taking control. That's per the statistic model. The dynamic model saying pretty much the same thing, but rather than a strong inactive phase in control 15 days out or 2 weeks out, says all of a sudden it's supposed to get very weak as it hits we'll call it a low pressure bias that is developing in this area. More on that to follow. Looking in phase diagram charts, a way to just drill in a little bit deeper. So what are we looking at here? Well, the MJO moves from west to east around the equator. So from the Indian Ocean, over the Maritime Continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, and back to the Indian Ocean. The heavy dot here is where the active phase of the MJO is. So we'll say maybe over the Central Pacific, not maybe into the East Pacific yet. The further away from this circle it is, the stronger the MJO is. So moderately strong, and then 3 different projections 2 weeks out of where the MJO is supposed to be. All of them, this per the statistic model, suggesting basically in the Indian Ocean. One says extremely weak, one says pretty strong, unknown. But if the active phase is in the Indian Ocean, then on the exact opposite side of the planet over here, the inactive phase is likely in control. The dynamic model, pretty much suggesting the same thing. Same position, maybe racing a little bit further to the east into the East Indian Ocean, and the MJO active phase very weak, just right on the circle line there. So neither chart suggests an improving pattern, if anything, a weakening storm production pattern over the next 2 weeks. Here's the upper level chart, 40-day forecast, 5 panels, or 8 panels, each 5 days long. There is South America, Central America, the equator right there. Dateline roughly right in here. The Philippines, New Guinea there, Australia there. Oranges and reds, dry air, not favorable for precipitation, the inactive phase of the MJO. So you can see the greens, the active phase of the MJO. We're just interested in the Pacific Basin here too. And you see, so a weak active phase moving into Ecuador, across the equator, and towards the Atlantic, we'll say by the 5th of May, so a week from now. Inactive phase, strong in control, traversing the Pacific through about May 20th. But then a moderate to moderately strong active phase forecast developing in the West Pacific, so May 15th. So what do we have? About 2.5 weeks of dead zone according to this, and everything else sort of suggests that too, until the next active phase sets up that would then open the window for storm production into about the end of the model run, so the 4th of June. And then at that time, the inactive phase starts building in the West Pacific. Another way of looking at the MJO, this is the east-west component of the wind. We want dying trades. That's what supports storm production. All right, whole planet on one chart. The dateline runs right up the middle. The far west Pacific starts about 135 east, so right about here. And the Kelvin wave generation area ends right about here. The solid contour is the active phase of the MJO. So you can see, oh, and there's today's date right there. So you can see the active phase pushing through the Kelvin wave generation area today, and forecast to be out of it by about a week from now, let's say April 30th, something like that, and westerly anomalies moving off into the East Pacific. If you're going to get a Kelvin wave formed, this is the sweet spot right in here from about what was, we'll say, May 28th through about, March 28th through about April 30th, something like that. And we suspect that has probably happened, in fact. But also notice that west anomalies are supposed to start not building, but sort of getting a semi-permanent weak footprint in the West Pacific from here on. So that the solid contour is the active phase of the MJO. This dotted contour is the inactive phase. And you see little hints of it weakly pushing through the same area, and strong easterly anomalies building once it gets beyond the date line. But in the Kelvin wave generation area, this sort of persistent weak west anomaly pattern is to take root. That's exactly what we want, because that will help clear out the remnants of La Nina. We'll get more into that in a moment. And you can see here the purple low pressure bias. You can't really tell it here, but we'll have another chart, and it suggests a low pressure bias building in the far west Pacific. That is exactly what we want to see to get rid of La Nina. And then the 3-month outlook. So this is the same chart, but flip it over. Past performance is down here, and you can see, so where are we? Dateline is right there. Kelvin wave generation area starts right there. I'm looking around the microphone and the camera and everything here. So if you wonder why I'm not looking right at you, that's because I'm trying to look at the chart, trying to look around a bunch of obstacles in the way. Okay, but what you see is, and this is past performance here, the forecast is up here, and this clearly marks the difference in pattern. East anomalies on the date line, this was back in December. Strong east anomalies, little bit of west anomalies, and that was, we think, associated with active phase of the MJO, which produced a Kelvin wave, which is in flight right now. More east anomalies, but notice as we get into pretty much from today on, westerly anomalies are forecast for the next 3 months over the Kelvin wave generation area. And these easterly anomalies that were locked on the date line now become more centered pretty much due south of California. So what's that? They talk about the triple R threat, the ridiculously resilient ridge, high pressure in the Gulf of Alaska. Yes, this is clearly suggesting that would be the case. But from a surf perspective and from a jet stream perspective, both in the north and southern hemisphere, having westerly anomalies over the date line is exactly what you want to have, and that might set us up long term to at least push the ridge out of here. It'll hang around. The remnants of La Nina will hang on, and it'll sit here probably into the fall, at least late fall. But hopefully by then the demise of La Nina will also ensure the demise of the ridiculously resilient ridge. All right, but we digress. All right, so let's overlay MJO activity here. All right, so you can see this is the solid contour is the active phase of the MJO moving from west to east and out of the Kelvin wave generation area in the next 5 days. An inactive phase of the MJO, pretty weak, is forecast from, we'll say April 28th, something like that, through about May 26th in the Kelvin wave generation area. But notice, west anomalies holding, no east anomalies in the Kelvin wave generation area. That is a major step forward. And then after that, it's nothing but the active phase of the MJO and pockets of strong west anomalies nonstop as we get almost to the end of July. A significant change in pattern as compared to where we've been the past year or more. Why is that? Let's overlay the low-pass filter, and you can see it here. The dotted contour is a high-pressure bias that's been in control of the Pacific with 1, 2, 3, 4 contour lines, bulletproof. That's what's feeding all those easterly anomalies back in December and January. That is supposed to be, you can see it here, just moving slowly east to a point centered due south of California by the end of the model run. And this low pressure bias, which was strong in the Indian Ocean, is now starting to shift. Look at that little indentation there in the next 4 to 5 days. Significant shift eastward. It's already, the leading edge of it is in the Kelvin wave generation area. And at 180 west, as you get into somewhere here in maybe June, this low pressure bias is supposed to start filling the Kelvin wave generation area from July potentially onward, which could set us up for a much better pattern moving into the fall and winter of this year. Now, it takes a while for the jet stream and the air pattern to change around the planet. It just doesn't happen overnight. It's a 3 to 5 month period for things to get reconfigured. But this suggests that by, as we get the start of the summer, things could start changing, which would set us up by maybe a Thanksgiving or so. Significant change in the weather pattern, and maybe we could eke out a decent winter next winter. But still, through summer, it's going to be pretty rough. All right, so let's go take a look what's going on in the ocean. This is data from the TAO buoy array. This is the East Pacific here, West Pacific here. The X's are anchors on the buoys strung across the Pacific. The actual X's, individual sensors, you can see them. Some of them are out here, some of them are out here, but they use a model to fill in the gaps to make the best of what you have. What you see, actual temperatures, centigrade, 28 degree isotherm, centigrade. The far West Pacific, the 24 degree isotherm line. We've been monitoring that. All winter it was back over here, like 165 east. Today, it's at near, we'll say 171 west. Appears to be stabilizing there. The 24 degree isotherm, which went right to the surface at 140 west this winter is now all of a sudden deep, thick, pushing the whole way across the Pacific, suggesting warm water is pushing off to the east. Okay, quite different from what we saw during the winter. But it is the anomalies, differences from normal for this time of year that matter the most. In this winter, it was all cold water right here, very cold water, filling the whole way over to about here. Now we have warm water 3 degrees centigrade above normal, down about 150 meters in the far west Pacific. We think this is potentially a new building Kelvin wave. Remember the active phase. So where are we here? Let's Kelvin wave generation area. So the date line is right here. Okay, this is the West Pacific here. So Kelvin wave generation area runs from here on off the chart. If you have westerly anomalies, winds blowing this direction, like that, we'll take this warm water, push that's down at depth, and start dragging it across the Pacific, just like this. This is a Kelvin wave in flight, Kelvin wave number 1 from a westerly wind burst in February. This looks like to be Kelvin wave number 2 building. It takes 3 months to make the journey across the Pacific. Here is another model. Here's the leading edge. This is a higher res model. The leading edge of the first Kelvin wave here, poised to erupt to the surface at about, where is that? Oops, I'm sorry. We're going the wrong way. 110 west, maybe 105 west, so south of Mexico. And here is the last little remaining bits of cool water from La Nina here, eking its way up to the surface, getting caught by the trades and pushing off this direction. But you see a massive pool of warm water here in the West Pacific. This looks to be Kelvin wave number 2 starting to make its journey across the Pacific. We expect the leading edge of Kelvin wave number 1 to start erupting to the surface somewhere just west of the Galapagos, while pushing over the Galapagos and into Ecuador over the next couple of weeks, and then with more behind that. Sea surface height anomalies, not temperatures, heights. So what are we looking at? Here's South America, Central America there. This is the equator. This is the date line. Right there is New Guinea. Hawaii, where is it hiding? Right in there. Okay. Date line there. So what you see is positive anomalies, 5, 10 centimeters. So this is from the Jason 3 satellite data. It rotates around the planet, just constantly measuring the height of the ocean. You strip out the waves, strip out the wind waves, strip out the tides. You see the ocean is 10 centimeters above normal here in the west, and pockets of normal here. When you have warm water at depth, and we think there's this giant tongue of warm water going to somewhere around right in here, the whole way under the equator, warm water expands. When it expands, it pushes creates a little bump on the ocean surface, and that's what's going on here. If trade starts slackening, then that also would create a bit of a bump on the ocean surface. So just another way to say, and what we did see was this big triangle of negative anomalies all winter long in here, and now that's all losing form completely. The peak of the negative anomalies which were here are all gone. It looks like we're trying to move towards a neutral pattern. Here's another way of looking at it. Upper ocean heat anomalies. So here was the beginning of La Nina in May. It was actually in April that it started. Cold water, this is the East Pacific, this is the West Pacific here. Warm water, trade started building, warm water started getting sequestered in the far West Pacific. Cool water and upwelling took over the entire East Pacific until about March. And there was a little active phase of the MJO in February. It wasn't even much. Trades just backed off enough of it because so much warm water was here and found an opening and spurted off to the east. Kelvin wave number 1 in flight here. You can see it at 95 west. So, and Ecuador is over here at about 80 west. So making its way across. You also see here the beginnings of what appears to be Kelvin wave number 2 from the active phase of the MJO that's still going on at this very moment here. So, but also notice the total amount of latent heat energy that was here, because it's being pushed off to the west, is starting to decline as well. Upper ocean heat anomalies from the date line off to a point about south of Mexico. Cold water, cold water, cold water since May 2020 for the whole year. And now all of a sudden, a warming, and this is the upper 300 meters of the ocean, suggesting warm water is starting to take over the balance of the Pacific just outside of the Kelvin wave generation area. That's exactly what we want to see. Sea surface temperature anomalies in the Pacific. All right, so there is South America there, Central America, Mexico, Baja, the equator right there. Okay, the oranges and yellows are warmer than normal temperatures this time of year. The blues colder. Notice extreme upwelling, though it's much better than it was even a week ago along Peru. We think what's happening is the Kelvin, and the equator's like right here. So that Kelvin wave is barreling across right in here, and we think what it's doing is squeezing the last bits of cold water at depth up to the surface along Peru, and it was all in this area, but even that is fading. This is the size and the intensity of the cold water is fading almost daily along here. At some point, we are expecting to see these oranges and reds start building in coverage all along in here. And when that happens, we'll know the Kelvin wave is starting to erupt. But for now, remnant cool waters from La Nina. Now notice, this is on the equator here. These cool waters are south of the equator. North of the equator, here's another view of it here. There's warm water. So it's sort of this, we're halfway there. Warm water north of the equator, cool water south of the equator. We're not out of La Nina yet, but we're trying to get there. And also notice, so the official El Nino monitoring region is from 120 west. So from right here out to about 170 west. What's that out? That's 180. So right in here. So you can see for the most part it's still cold water in the Nino 3.4 region, the official El Nino monitoring region, but it won't take much for this to start warming up. The trend for the past 7 days is sea surface temperature trend. There was a fair amount of warm water developing or right here along the equator from Ecuador out almost to a point south of Mexico. Today it seems to have backed off, but we suspect that will come back. Give it a couple of days at most. Otherwise, a neutral surface trend. At least it's not cooling, which is where we were for a year. And then the backed off view again. The upwelling along Peru, the warm water north of the equator, cool, weak water south of the equator, and then still the lingering remnants of La Nina in the core of the Nino 3.4 region, the official El Nino monitoring region. Notice lots of warm water, at least on the surface, sequestered here in the West Pacific and all down in here. And our theory is that when you get an active phase moving even over here, it takes this warm water, bleeds it through the islands, squeezes it out north of New Guinea, and then starts building a reservoir of warm water at depth right in here. And you can pretty much see that on some of the depth charts. And then as the active phase continues pushing across the Pacific, it takes that warm water and then just blasts it because there's no significant islands to block anything here. Pushes it the whole way across the Pacific. Again, a 3-month track before it erupts off of Ecuador. Sea surface temperature trend in the Nino 1.2 region is the area right there by the Galapagos on the equator and Ecuador. Temperatures did rise a little bit, but they've dropped significantly, but are holding at 3/4 of a degree below normal, 0.758. Again, this is, we believe, all attributable to that upwelling of deep, cold surface, subsurface water being squeezed to the surface, driven by the approaching Kelvin wave. In the Nino 3.4 region, temperatures have risen. They are 1/4 of a degree below normal, 0.270 at 1/2 degree for 5 consecutive 3-month periods. That's the threshold for La Nina. Officially, we are out of that. Not for long. It's been, about 2 months, something like that. But still, that's better than being in La Nina. We want to really be on the warm side here. We're not, but we suspect it's only a matter of time. So what does the atmosphere think is going on? Is the atmosphere responding to the change in water temperatures? All right, so the Nina, what is this? The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Darwin's effectively in the Indian Ocean, Tahiti's in the Pacific. When pressure is lower in Tahiti, the index goes negative. Today, it's minus 13.27. That suggests that pressure in the Pacific, at least for today, is lowering. And that's what we want to see, a negative index. Now, you kind of go back and look over time. Well, it hasn't been negative. Well, that's because we're in La Nina, and La Nina is characterized by high pressure filling the Pacific. Okay, but this is kind of a noisy indicator. Let's go look at the 30-day average. It's just a 30-day average of all these numbers. And today, we're almost dead neutral, 0.20. And looking down, we have been hanging near neutral for about a month. The 90-day average is the longer range. It's sort of the El Nino La Nina indicator. And even it is dropping. It's at plus 4.43. But you can see it was up at nearly 10, and it was up higher than that. I think it was up towards 12 or 15 at one point. So we are slowly, remember I said the atmosphere takes a long time to respond, and this is an atmospheric index. The ocean is changing. The ocean's deciding that it's time for things to change because the atmosphere, the trade wind pattern is weakening, and that in turn is allowing, they reinforce each other. The atmosphere changes the ocean picks up on it, starts reinforcing the atmosphere, and when you all go to strong high pressure and trade winds, that's La Nina, both the ocean and the atmosphere reinforcing themselves. But at some point, it kind of just goes, I can't do this anymore, and it collapses, and that's where we are. The pendulum is swinging back to the left to a warmer regime, and at some point, this will get down to about 0, and then we'll be in ENSO neutral. Here's the 30-day moving Southern Oscillation Index graphed out. You can see back in 2020, we were, in January, we were at negative, which is weak El Nino, and then in April, we just started rising, positive, went to La Nina, peaking up at 20, about plus 20. But notice a big decrease lately, hovering around neutral. We're getting ready to go into the inactive phase of the MJO, so we'll see how much we bounce back, if at all, or whether we just hang here or whether we start to move neutral. But right now, at least for the moment, we're in a better position. It needs to hold at least neutral or go negative for 4 or 5 months here to allow us to completely wipe out the effects of La Nina. With that in mind, we're going to take there's another long-term thing. So we talk about, there's the change in seasons, right? Warm and cold. Then there's the MJO, this 30, 40-day cycle of high pressure, low pressure. Then there's El Nino, which effectively is a high pressure, low pressure thing in the Pacific that affects the whole planet, but that runs on a 5 to 6 year cycle, something like that. And then beyond that, there's the Pacifical Decadal Oscillation, which we're not sure how long it runs, anywhere from 20 to 30 years. And so there's a warm and a cold phase with that too. Going back, let's see if we can do this. So you can see back, and this is going way back, 1945. The blues are negatives. Now, that doesn't mean you don't have El Ninos and La Ninas, but the cold phase of the PDO, which ran from 45 to, let's say about 1975, was characterized by, it's like a giant long-running La Nina, cold temperatures. Yes, you have your warm peaks, but predominantly cold. Then we got into 1978 through 1998, and it peaked with the massive El Nino of, 97, 98, and also in there was a strong El Nino in 82 and 83, but predominantly warm. Then with the 98 El Nino, we crashed and went back into the cold phase of the PDO. We were thinking that maybe we had entered the warm phase of the PDO, and rather quickly in 2014-15. But now it's kind of hard to say where we're at. The interesting part about this is look at this long-running cold phase here. It was cold, 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 got warm, and then notice the coldness continued, but the amplitude was much less on the back end than it was on the front end. Then, same deal here. In 98, we went very cold for, almost 20 years, 18 years. Now we're back cold, but not nearly as cold. The question is, are we out of the cold phase of the PDO, or are we still in it? We don't know. It'll be another 5 or 8 years before we know. And if and when that happens, if we're actually in the warm phase, well, we'll probably be halfway through the warm phase before we know that we're in it. Anyway, just another little tidbit to look at. So for right now, in the northern hemisphere, hey, there's a gale forecast, extratropical cyclone forecast in the West Pacific. No major swells expected from it, but rideable surf certainly for Hawaii could result, and also maybe for the U.S. West Coast. More of a novelty thing than anything. Also, southern hemi swell is actually hitting. It was supposed to be a lot stronger than it was, but there were waves this weekend. It was a little, quite a bit overhyped, I would say, but that's the way it goes sometimes. But there was surf this weekend. That swell is fading. Another small southern hemi swell is coming in midweek. Nothing epic. And then maybe some more behind that. Another southern hemi system is forecast under New Zealand, pushing across the Pacific. So waves there. And then wind swell cranking up by the weekend as well. So there is surf. Nothing epic. Nothing huge. But there is something to ride. Make the most of that. Long term, the good news is active phase of the MJO. Yeah, it's fading out, but west anomalies are supposed to be holding. And then another active phase beyond that way. 1 Kelvin wave in flight, possibly 2. Significant change is potentially occurring in the Pacific to get us out of this La Nina. Of course, we won't know for a little bit. We're still in the spring unpredictability barrier. That runs from March into about mid to late May. So the models are still kind of on and off. Oh, in fact, we didn't look at the model. Let's go do that real quick. Long-range outlook, sea surface temperatures for the Nina 3.4 region. Today, we're darn near neutral, just a little bit under, maybe 0.2 of a degree. Forecast holding for neutral into July. Then according to this model, falling. It did have us in some horrible state now, saying, well, down to maybe a 0.5 degree below normal by November, December. But I suspect as we get out of the spring unpredictability barrier, this will rise some more and be hovering. This tends to be a doom and gloom model. The other models are all suggesting neutral. So things slowly improving on this model. Just a bit of unknowns of the strength of the Kelvin waves and how all this is going to play out. So long term, yes, we're not exactly sure how it's going to happen, but it looks like we're setting up for ENSO neutral. No model is suggesting that we're moving into El Nino for the fall, but neutral is certainly better than raging La Nina. We'll take it. So for now, we're cautiously saying the future is looking better. Guessing at the fall, the late summer probably is not going to be great for surf production until the low pressure bias moves over the Kelvin wave generation area, which isn't until June or so. And then it's going to take a couple of months for the atmosphere to change above it. But we suspect somewhere between maybe Halloween and Thanksgiving, a change in the atmosphere for the better will set us up for at least, hopefully, a normal winter beyond that. And even that is still a pretty wild guess, much uncertain. But at least we're looking potential for a brighter outlook. All right, if you enjoyed the video, give us a thumbs up. We appreciate it. If you haven't subscribed, please subscribe. If you don't want to do that, that's okay. Go to stormsurf.com. Go look at the top when we post the video. The link to it will be at the top of every page of the site. You can just view it there. All the data that's presented is available on stormsurf.com. Comments, if you have questions, please write some comments there. Thumbs up, again, are always appreciated. And other than that, we don't have any big plans, so we'll be doing this next week. Same time, same channel. Thanks for watching. See you then. Stay safe and get some waves.